Hello, I welcome everyone here at IAC in Milan, and I'm so happy to welcome you. And I'm happy to welcome Bill Diamond or William Diamond from the SETI Institute. He is a director of the SETI Institute, and he is joining us for an interview today. Welcome, William.
Thank you very much. Wonderful to be here and great to have a chance to talk to you.
Yeah.
One of our great artists.
Yeah. Uh, is it the first time that you are here?
It's not the first time I'm at IAC, nor the first time I'm in Milano, but first time I'm in Milano at the IAC.
Yeah, this is clear. And tell us about more about City Institute.
Sure. Well, SETI, as you may or may not know, is an acronym which stands for the Search for Extraterrestrial Intelligence, where we use technologies such as radio telescopes and optical telescopes to look for signs of technology coming from beyond our solar system, which would be evidence of advanced civilizations and technologies serving as a proxy for life and intelligence in the universe beyond our solar system. So that's our core mission. Our mission is to lead humanity's quest to understand the nature and prevalence of life and intelligence in the universe, and then to share our work with the world, which we do through education and research programs. So it's everything from microbes that might be on Mars or interesting, perhaps more complex life forms that might be in places like Enceladus or Europa or Titan, to possibly advanced civilizations beyond our solar system.
Okay, I have a question. Microbes are not really intelligent, but SETI stands for the search of intelligent life at the universe. I know it would be a great impact for us if we find any life at a universe, but you are also looking for not intelligent life.
Yes, that's right. I mean, I think one of the questions we have that we're addressing is, what are the conditions under which life gets started? We have life on this planet. It's right now the only existence theorem we have for life in the universe. But I think the statistical evidence is becoming overwhelming that there's likely to be abundant life elsewhere in the universe. Now, is it complex or simple? Is it intelligent or technological? We don't know yet, but I think that even microbial life, even basic life existing in some other environment, particularly with a unique biogenesis having nothing to do with the origins of life on Earth, would be profound. It would be profound, however, primarily because it would further imply the likelihood of intelligent technical life beyond Earth. And I think that's ultimately what's the most exciting and interesting pursuit that we have, is to look for other examples of advanced technological civilizations in the universe.
It's interesting. The Sostek says if we find intelligent life, we will be find it in technical forms, and that I can imagine because distances are so far. Though we also are sending uh, space probes into space. But do you think, tell us a little bit more about SETI, laser SETI, because I have learned that you have a new project, laser SETI. Maybe you can tell us a little bit more about it.
Sure. Well, as a very rough background to SETI overall, there are three ways to look for life in the universe. One is what we call in situ, which means sending instruments and technology to places of interest, which we're already doing in places like Mars. And we have the new Europa Clipper mission to look for evidence of biology on the moon Europa. The second way to look for life is through remote sensing. This is using observational platforms, including the James Webb Space Telescope, which has the capability to probe planetary atmospheres of so-called exoplanets, planets beyond our solar system, and look for either biosignatures or technosignatures. Biosignatures meaning an atmospheric composition that would be difficult to explain without the presence of life on the surface. Technosignature might be a molecular compound such as chlorofluorocarbons in the atmosphere, which we don't believe nature produces. So that would be a technosignature. And then the third way to look for life and intelligence is SETI, or using radio and optical instruments to look for signs of technology that can actually manifest across the galaxy, which means the parameter space is much larger than we can consider with remote sensing or in situ instruments. And the two types of SETI we're doing now are in the radio spectrum, using radio telescopes to look for radio signals, because radio is an effective medium for transmitting information over vast distances, including interstellar distances. But now we're also looking for technosignatures in the form of laser pulses, or what we call laser SETI or optical SETI. And this is because lasers are also used for communication, for propulsion. They're a very well-defined non-natural phenomena. In other words, they would be very distinguishable from natural background phenomena that we observe in the optical domain. So looking for laser pulses, it becomes yet another interesting way to look for signs of technology beyond Earth, in the universe, and therefore another viable means of doing SETI. So SETI is interesting because we can't, as a technological civilization in our own right, we can't look for technologies that we ourselves haven't developed or understand. And so as we develop new technologies and come across new kinds of physics that can be detected over, say, interstellar distances, that will give us new instruments and new tools to use for SETI. But for now, we are primarily focused on and confined to work in the radio spectrum and in the visual spectrum, in both radio SETI and optical SETI. So laser SETI, a series of camera systems around the world at different observatories, monitoring the skies for millisecond or microsecond pulses of monochromatic, meaning single wavelength or single color light, that again would be evidence of technology and not nature.
And do you think there are any other ways to search for extraterrestrial life except laser or radio signals?
Oh, absolutely. But again, some of them are going to be limited to planetary environments that are closer into us so that we can observe them. But for example, there's one of the interesting things that we're getting from both the Kepler mission and the TESS mission is so-called light curves, where we observe a star and we observe the periodical dimming of starlight that might be the result of something orbiting around that star. And one of the more interesting phenomena that is at this point, in the domain of theory, is something called a Dyson sphere, where a very advanced civilization might be harnessing the energy from their host star by building these massive structures that can harness that energy, transmit it to the planet, and then they have, a sort of never-ending, clean, reliable, renewable source of energy that solves the kinds of problems we're dealing with on Earth in using fossil fuels and other things for our energy. So looking for Dyson spheres, which we can do by interrogating data sets that are otherwise used to find exoplanets, such as the TESS mission from NASA and the Kepler mission, become another way of looking for so-called technosignatures. As I mentioned before, looking for molecular compounds and planetary atmospheres that nature doesn't produce is another interesting phenomena. Looking at planetary systems where something unusual appears to be going on. For example, we have what's called the TRAPPIST system, which is a system of 8 planets orbiting an M-dwarf star, where at least 3 of those planets are in the habitable zone of that star. And if, for example, we were able to observe and characterize the atmospheres of particularly the habitable zone planets, and we found 2 that were very similar or almost identical, one might infer that some, planetary scale geoengineering has been going on. And so, there are lots of different ways to conceive of signatures of technology besides, radio and optical. But radio and optical, again, have the benefit of being a phenomena that we can observed from vast distances that we can't. These other phenomena are only observable from 20, 30 light years out.
Thank you. I have here Bernard
Hello. Nice.
Foing, Professor Bernard Foing. He's our president and welcome. I'm really nice to join you. And
Yes. So, okay, it's great to be here at the International Astronomical Congress in Milano, where there is so much happening. So, I am also member of the program committee of IAC, organizing the Solar System Symposium, where we study all planets of the solar system, but also we are looking at exoplanets. Yeah. And also we have an astronomy session, we have a life science session, and clearly, SETI has been a very instrumental in developing so awareness of what to do to listen to the universe. But in the meantime, our view of the universe has completely been changed by some of the missions that we have flown. So even before we get some civilization, there is a lot we have learned, for instance, on the so-called the Drake equation. So which has many components. Some of them are, for instance, how many stellar systems are there in our galaxies? How many Earth-like planets are there? How many are habitable in the sense of having surface water on their surface? Or are there also other worlds, like the one we discover around Jupiter, which are icy moons, which could be habitable in that subsurface? Yes. Actually, I was always very interested by the search for extraterrestrial worlds. Yeah. And we had in Europe a number of missions. A small one called Corot before Kepler, where we detected the first rocky super Earth. Yeah. It was quite a challenge, but then Kepler has completely changed the field, detected so many, and TESS also has continued. I have a number of students that have analyzed these light curves, trying to discover their own planet using machine learning and other techniques. Yes. So it's a booming field. Totally. And now we go to the next challenge, trying to detect the signature of the atmosphere of this planet to know, okay, what are they made of? Could they sustain life? And so we started with the Hubble Space Telescope, studying some of this transit spectroscopy. We have now James Webb Space Telescope. But in the future, Europe is preparing a mission called Ariel, where we are going to measure the composition of many of these planets. Yeah. And we have also another mission called Plato, which is going to look at all the nearby stars and to try to characterize the presence of planets, but also the environment from the stars. So clearly a lot of work. So if you want to join this search for extraterrestrial world, there is many. Right place. They are in the right place. Many things to do, and then still we need some new technologies of breakthrough listen. Yes. As we can say, to listen to some of the signal from those planets, some normal natural signals, and ability to see if there are some anomalous signals coming from there. But so it's a great pleasure to have you to inspire us. Now let's get a question. What do we do? What do we do when we detect a signal which is really a sign of an extraterrestrial civilization? Do we connect with them? How do we process? Is there a risk? So what are the risks and what are the benefits of communicating with such civilization?
Great. So you want to hold them?
You can.
Yeah, I can do that. Okay. Well, this is a great question, and it's one that is coming up increasingly often, which I think is an indication that there is both growing awareness of, the ubiquity of planets and the ubiquity of potentially habitable worlds, and therefore the increased likelihood that we will make a profound discovery relatively soon. And of course, the discovery of life in its most basic form would be one level of excitement, but a signal, a definitive signal indicating the presence of an intelligent species and a technical species beyond our solar system would be profound in the extreme. A lot of attention is now going to what we call post-detection protocols. And in fact, there's an organization called the SETI Permanent Committee, which is a member of the IAC and the IAA. And its annual meeting, the Permanent Committee meets at the IAC meeting. So we actually had our formal meeting today. And one of the main topics was updating and modifying a UN agreement that was written now many decades ago in the 80s to actually get institutions and organizations and individuals involved in this work to sign on to kind of an agreement of what we would do in the event of an interesting detection and what the protocols are. I will say that, all good science, you know that you're doing science when you answer a question, and in so doing, you just raise 10 new questions. That's what science is all about. It's not about answering questions, it's about asking questions, and it's about asking the right questions. And so if we make a discovery, lots of questions will arise. Well, what is the nature of that discovery? Was it, a radio transmission or an optical transmission? Does it appear to have structure or content such that we might infer that it contains information? How far away did this originate from? Is it within, tens of light years, or is it 1,000 or 5,000 light years away? Because, SETI is really not an endeavor that's intended to have a conversation. It's not about making contact so we can communicate with one another, although that would be an extraordinary outcome if possible. It's primarily about making the discovery for what it implies about our own future as a technological civilization. But in terms of this idea of communication, if we found that that the source of such a signal was within 20 or 30 light years, you could conceivably have an intergenerational communication channel with this civilization. But among the protocols we're looking at and trying to agree upon are, how do we announce the discovery to the public? And I think the answer is in the most specific and scientific terms we can, i.e., not jumping to conclusions, but sharing with the public what is the nature of the phenomena that we've observed, where does it come from, and what does it look like, what is its structure, and the protocol is also one of verification. So if an observatory like one of our own, or a Breakthrough Listen Observatory, or some other organization makes this discovery, we want to verify and get other observatories to see if they are observing the same phenomena at the same location, and we can verify that it's not radio interference from our own technology and comes from beyond our solar system. So verification, sharing the nature of the discovery, the details of that without, again, sensationalizing or jumping to conclusions. And then again, characterizing what does it look like? Where does it come from? How far away? How far away translates to how long ago? If it came from 50,000 light years, which would be about halfway across our galaxy, we would have no way of knowing whether the civilization that emitted that signal even exists any longer. And so that would be a very different kind of discovery than something that was within 10 or 20 light years. So there's a lot of attention being focused on post-detection protocols, how we communicate to the society, to the public, and what are the implications for society, for religion, for politics, for science, for economics, et cetera. I personally would like to think that such a profound discovery would be a uniting, discovery for humanity, that we would come together and say, we are one species on one planet sharing one set of precious resources, and we should start behaving that way. And this other civilization, where the statistical probability of finding another civilization is such that they're likely to be much older than we are. And if they are, they're probably much wiser than we are. They've learned to establish a balance between their own existence and the resources of their planet or their environment, which we are not doing right now. We are beyond a balance point, and they've solved problems that we have yet to solve. So I personally would like to think that such a civilization is not a threat. That's my personal opinion, because they've had to solve the kinds of problems we're facing today that I think can only be solved through cooperation and rather benevolent behavior instead of malevolent behavior.
But I mean, on Earth, we have also discovered very different life forms. And is it true that we are so wise, or are we wiser than some of the life forms that we are, in fact, putting in danger? So I hope the extraterrestrials do better than us. But now I wanted also to say, SETI clearly is looking at this question, are we alone? Alone in the sense, alone with other civilizations where we could learn from, but also what I'm very impressed in SETI, it has developed a set of research programs in many other areas, yes, like astrobiology. There are many people also looking at micro origin of life on Earth, yes, also astrobiology, extreme of life, and so on. And this is also teaching us a lot about, what is life, how we have to cherish it, and also, so eventually we are going to detect microbial life, mm-hmm, on another world. It may start at Mars. It may be in one of the moons of Saturn, Enceladus, or Titan. It could be subsurface in some of the moon of Jupiter. And so in this area of, searching the limit of life, and did life occur in different conditions in another world? So what are the latest activities of the SETI Institute?
Sure. Well, these are the big questions, like how did life begin? What are the origins of life on Earth? I think people often ask, well, why can't we conceive of life, on some other foundation besides carbon-based life? And, on the one hand, I think that's a fair question. I think on the other hand, what's extraordinary about life as we know it and as we've discovered it is that life developed on Earth built upon the most basic and most abundant elements in the periodic table, carbon, hydrogen, nitrogen, oxygen. These are, low atomic number, highly abundant atoms that exist. They're everywhere in the universe. Water is everywhere in the universe. And so therefore, and carbon is this Lego brick of, of a building block foundation for long chain molecules that are required for complex life and ultimately conscious beings such as ourselves. So, to the extent that we think in the known universe, the laws of chemistry and physics are likely to, be the same, so too may the laws of biology. That biology may also follow certain universal rules that, while the results can be vastly different because of the variety that's possible, nevertheless, the building blocks are similar. So these are the kinds of things that we're trying to study and evaluate. But the other thing that is very important in this kind of work is what we call the coevolution of life and environment. Yeah. That life imparts an impact on its environment, and equally the environment impacts and shapes life. And life on Earth and the Earth as an environment and a habitable system have co-evolved over 3 billion years. And this is also going to repeat itself anywhere that life occurs. And of course, as a result of that coevolution, with a different set of starting parameters and a different set of evolutionary processes, the results could be wildly different, and could be truly amazing. But these are really in important understandings, this dynamic nature of life, and its relationship to its environment and how the two influence each other and co-evolve.
So now, last provocative question: do you think it's likely, because we don't know how long a terrestrial civilization is going to last,
right?
But is it likely that at some stage we could receive a signal from an artificial intelligence, an AI on another world that has taken over the existing biosphere? And so how do we react to that? If we receive an AI intelligence signal from another world?
Well, I think the thing about a technological phenomena observed from another world is we might not understand the nature of the beings that sent it, unless there's some clear and obvious indication that the origins of this phenomena are not from some organic life form, but rather from some artificial intelligence life form. either way, the discovery would be significant. I mean, a lot of people are asking the question, is the next evolutionary step for intelligent life on Earth, the disappearance of biological intelligence and the emergence of artificial intelligence? It's possible. And of course, if, biological life, imparts problems in its environment that are ultimately existential threats, then, one might argue that for the rest of the species on the planet, we'd be better off with an artificial intelligence, in charge of things. Who knows? But I obviously, if we made a discovery that we could infer came from an artificial intelligence rather than a biological intelligence, that would also be a profound message, because it would probably also perhaps be some indication of what's in store for intelligent life on this planet.
Thank you so much.
The last question for you. If an alien contacts us, what would be the question you would ask?
What question I would ask them?
Yeah.
If we could have a conversation,
yeah,
I would ask them, I guess I would have to ask them two questions. Did you face the existential threats of becoming technological that we currently face? Question one. And question two, if so, how did you overcome them?
I thank you so very much. Thank you to Bill Diamond from the SETI Institute.
Pleasure. Thank you for having me.
Yeah, thank you to Bernard Foying, Professor Bernard Foying.
And
yeah, and I would like to invite you to our after work session because we have now music. Here is playing a very, very good saxophone.
Awesome.
And he's playing guitar, and Adriano is playing, Bernard is playing piano. So wait a minute, relax.
Great.
And we have a nice evening.
All right. Super.
Okay, bye.
Bye, everyone.
And so, on behalf of Space for All, this is a type of signal we could send to the extraterrestrial. Some good music. Yes. Welcome for the Space for All happy hour of the International Congress of Astronautics in Milano. All the best to you.